Hey team, in this video we're going to look at the Ethereum Gravatar quickstart project. This can be found in the quickstart section under Ethereum, clicking on the Gravatar simple project. Now we're going to index the Ethereum Gravatars created or updated on Ethereum mainnet. And you might be thinking, what is a gravatar? Well, first of all, an avatar is an image that represents you online. So a little picture that appears next to your name. But a gravatar is a globally recognized avatar. Now, an Ethereum gravatar is a decentralized avatar service using Ethereum addresses. So it's very similar to a gravatar, but instead of using an email address to identify a user, it uses an Ethereum address. And this makes it more secure and private, as you don't have to share your email address with the website or service. The first step when creating a project is to check that we have the required prerequisites. Navigating to Quickstart in the documentation site here, and then going to step 1, create a new project. You can see that we need Node, Docker, and the SubQuery CLI. Now let's do a quick system check in VS Code where I can run node-v, and if I've got Node installed, it will return a version, which here you can see is 20.3.1. If you don't see a version, it means you don't have Node installed, so do a quick Google search for Node and you can install it. Or if you're using brew on a Mac, you can run the command brew install node as well. After this, you'll need to install Docker, which you can again run via a Google search. And then the last step is to download the SubQuery command line. And you can do this by running npm or node package manager install -g for global subql CLI. Now, just a note that you need to have Node installed first before running npm, because when you install Node, the Node package manager gets installed along with it. Once this is installed, jump into VS Code and run subql-v to get the version, and you can see here I'm running version 3.5.1. Once you have all of these installed, you're now ready to start creating your first project. To create a project, we first want to run the subql init command. We can then provide a name for the project, such as eth_gravatar, and then I'll be presented with a list of network families. Let me scroll down to Ethereum and then choose the Ethereum network, and then I'll choose the Ethereum starter, which is the one for mainnet. All of a sudden, you can then see some files and folders appear on the left hand side here, which is the framework or the scaffold for the project. Next, I can provide my own RPC endpoint or just accept the default in yellow, which is what I'll do. And I'll do the same for the remaining fields. And then you'll see I get an option to generate more scaffolding from an existing ABI contract. This is a very neat feature, but what we'll do is we'll select no for now, and we'll create this from scratch. And there we have it. My project is ready to go. After we've initialized our project, we want to download all our project dependencies. So to do this, let's cd into our project first of all, and then I'll run yarn install. Now this will generally take about 30 seconds depending on your internet speed, so see you after this is done. The first file that we're interested in is called the project.yaml file, also known as the manifest file. And this can be viewed as the entry point to your project, defining most of the details on how SubQuery will index and transform the chain data. It also indicates where we're indexing data from and to what on-chain events we're subscribing to. So at the top here, you can see we've got a spec version and then the name of the project, various other parameters here, including our description as well, and a link to the default repository. The schema file here points to the location of the schema file, something we'll talk about shortly. And then the network section down below identifies the chain ID and also listing the endpoint where we're actually going to get our data from. We've got a dictionary field down here to help speed up indexing as well. And just a note that all of these fields don't really need to be changed. However, the data sources section here does. So what I'll do is update this first before explaining it. And to do so, let's jump back into our documentation here, scrolling down to our manifest file section, and I'll copy out the data sources part. Let's jump back into our code here and just select this, delete it, and paste in the new one. Now in this section, we've defined our start block, which in this case is around 6.1 million, which was when the Gravatar contract was deployed. We then have the address of the Gravatar smart contract, and then a link to the actual JSON API file, which I'll talk about shortly as well. And then down below, we've got two handlers, a handle new Gravatar function and also handle updated Gravatar. And these are effectively functions that get triggered when the project encounters a match on our filter. So these functions here will be triggered when the topic filter called new Gravatar or updated Gravatar is encountered on the logs of the Ethereum blockchain. And this is specific to the smart contract at the address we saw up above, 0x2e64, etc. And to get more information about this, it's always handy to jump back into the documentation, clicking on the manifest file here, where you can see the definitions of the top level spec, the schema spec as well. And then on the right hand side, if I go to the data sources section, it will define the various handlers that can be used when creating an Ethereum indexing project. The second file of interest out of the three that we need to change is the schema file. The schema.graphql file essentially determines the shape of the data that we want to extract from the blockchain. So jumping back into our quick start guide, let's copy out the schema file provided. You can see here it's one simple entity called Gravatar with 5 fields. If I copy this over, let's replace our existing schema file and save this. And the entities can be thought of as database tables and the fields within as columns within the database table. So here we've got ID, which is a unique identifier. We've got an owner field of type bytes. We're displaying the name and grabbing out the image URL, as well as the created block height. Let's jump back into the documentation here to understand more about the schema file, where you can see that there are a few elements to take into consideration. The first one is the ID field, which is mandatory, hence it has the exclamation mark, serving as the unique primary key. There are also various supported scalar types that you can see below, and you can actually get quite complicated with these entities and create relationships between them. You can create one-to-one, one-to-many, or many-to-many relationships as well. But in our example here, we've got just a very simple entity called Gravatar. The last file we want to modify is called the mappings file, and you can find it in the source directory mappings, and it's called mappinghandlers.ts. This is where a lot of the code happens, the transformation. So let's go ahead and jump back to our quick start project, and we'll copy out the mapping function, paste it into our project, and then I'll save it. And what you can see at the top here is we're importing some interfaces and some classes, and then we define some functions called handle Gravatar and handle updated Gravatar. The handle new Gravatar here receives an argument called log of type new gravatar log, and it's this argument that contains the blockchain data. We then log the block number or the block height to the console for debugging purposes, run an assert test to see if we have the arguments that we need, and then we create a new gravatar object and assign the various parameters to our fields that we defined in the schema. And then finally we call save on our gravatar object. The handle updated gravatar function works in exactly the same way, with one difference where we first go ahead and check if the gravatar already exists. If it doesn't, we go ahead and create it before updating it with the various parameters. To build our project, we first want to run a command called yarn code gen. What this does is it fetches the GraphQL schema and generates the associated TypeScripts. However, we do see we've got an error here because it's looking for a gravity.json file which doesn't exist. So to fix this, what we'll do is jump into the ABIS folder, and this is the file that we need to update. So let's jump into the manifest file and we'll copy out the contract address. And I'm going to go to a website called Etherscan, and then I'll paste the contract address here, and then I'll select the contracts tab. And it's in this location where I can copy out the actual ABI file here that you can see, because this is effectively an application binary interface to help our project understand how to interact with this particular contract. So let's copy this, and then I'll jump into the file here. Let's delete the existing content, add in our copied ABI file. I'll format the document, save it, and then I'll also rename it to Gravity with a capital G. I'll then run yarn code gen again, and we can see that it's run successfully. Next up, we want to run yarn build, which creates a distribution folder performing things such as code optimization, preparing for deployment. Finally, to start the project, we want to run yarn start docker. Remember to have Docker open and running in the background, and then you should see images being downloaded and then the various images running as well, such as Postgres, the node server, and also the GraphQL engine. Now with this running in the background, let's go back and copy out a query, this one here, because it's this query we're going to run in localhost in our GraphQL playground. Let me open a new tab, paste this in, hit run. We don't have any information coming back yet. You can see that we've got a rate limit that's been applied to the endpoint, but we do have some information coming back, which is great to see. Now what I'm going to do is just change the order like so, run this again, and I'm going to cross-check this. And the way to do this is, let's go into our smart contract in Etherscan, look at our transactions, and what I want to do is let's view all transactions. Let's go to near the end, and I'm looking for block 295. So let's go back one page. And I've got the block 295 here. So let me open up this transaction. Let's scroll down, show more. And I want to view the input here. Let's decode this data. And you can see I've got display name and image URL. And then I'll compare this to what we have indexed. And you should be able to see that there is a match where the display name is my name here. And then I've got example.com. And that's the same as what we've got in our index project. So there we have it, a very quick example of how to index all Ethereum Gravatars that were created or updated on Ethereum mainnet.